Okay, so are you ready to dive into something really mind-blowing today? We're talking quantum computers,
Oh, yeah.
the kind that make science fiction seem
Yeah.
like a total warm-up act.
Right.
And get this, Google just revealed their newest quantum chip, Willow.
Hmm.
And the tech world is seriously buzzing about it.
Yeah.
So we,
It's a big deal.
yeah, we thought so too. So we dug into Google's blog post, Meet Willow, our state-of-the-art quantum chip, to try to figure out what makes this thing so special,
Yeah.
why everyone is freaking out, and what it could mean for all of us.
Yeah. Let's break it down.
Okay, so first off, Willow accomplished two major things.
Two huge things that have been really stumping scientists for decades.
Right. Willow tackles a huge problem in quantum computing, and that's errors.
Yeah.
You see, as these chips get more powerful with more qubits, they tend to make more errors.
Yeah.
But Willow actually reduces those errors exponentially as it scales up.
It's
It's a huge victory.
yeah.
Yeah.
It's something that scientists have been chasing for almost 30 years. And it's not just tech jargon, this error correction thing.
Right.
It means we're finally on the path to building quantum computers powerful enough to actually change the world.
So no more quantum computers just crashing because of a rogue cosmic ray or something?
Well, it's not quite that simple, but you get the idea.
Okay.
Keeping those errors down is absolutely crucial for these systems to work their quantum magic.
Okay, point taken.
Yep.
Now, ready for the second mind-blowing thing?
Yeah.
Willow crushed a benchmark computational task.
Yeah.
It did in under 5 minutes what would take a top supercomputer longer than the age of the universe.
Wow.
We're talking billions of years.
Yeah, it's like comparing a snail to a rocket ship.
Wow.
It really showcases the potential of quantum computers to tackle problems that are way beyond even the most powerful classical computers we have today.
Okay, let's zoom in on that error correction thing for a second,
Right.
because I think that's where the real magic is happening.
Yeah.
Why are errors such a big deal in the quantum world?
Well, you have to understand that qubits, the building blocks of quantum computers, are incredibly sensitive.
Okay.
Even the tiniest disturbance can throw them off.
So you're saying even a stray photon could mess things up?
Pretty much, yeah.
Okay.
Imagine trying to balance a million spinning plates at once.
Oh, wow.
Any little vibration and everything comes crashing down.
Yeah.
So that's why what Willow achieved is so groundbreaking. It actually reduces errors as it scales up.
Okay, so that below threshold milestone that you mentioned earlier.
Exactly. It's a historic moment for quantum computing, something scientists have been dreaming about since 1995.
Wow.
This breakthrough paves the way for building large-scale, useful quantum computers.
Okay, now back to that supercomputer smackdown.
Okay.
Willow completed this benchmark task in under 5 minutes, while a supercomputer would need, well, let's just say a ridiculously long time. We're
Yeah.
talking about a time frame that's hard to even fathom.
It really highlights the difference in their computational abilities.
Yeah.
And to be fair, it's not even an apples-to-apples comparison.
How so?
Well, this benchmark called random circuit sampling doesn't have any practical use yet. It's more like a quantum obstacle course designed to make even the fastest supercomputer trip up.
Okay, and Willow just blew past those obstacles.
Precisely. And Google's been using this test for years to track their progress, so it's not just a random claim. They're serious about pushing the boundaries of quantum computing.
They even gave the supercomputer an unfair advantage in this test, right?
They did unlimited memory, a huge advantage in this kind of computational challenge.
Yeah.
And Willow still won by a landslide.
Wow. Talk about a knockout.
Yeah.
So we've got speed, we've got error correction, but there's another key piece to Willow's success, right? Quality over quantity.
Yeah.
It's not just about cramming in as many qubits as possible.
You got it. Willow's 105 qubits are all about quality, and that's just as important as the number itself. Imagine a team of highly skilled specialists versus a massive crowd of amateurs.
So Willow's qubits are the specialists.
Exactly. Each one is capable of doing its job with incredible precision and reliability. And this is reflected in Willow's performance across a range of metrics.
Okay, like their T1 time. Can you explain that a little?
Sure. T1 time measures how long qubits can hold information, which is crucial for complex computations. Think of it like remembering a phone number. A longer T1 time means you can hold on to that number for longer before it fades away.
So Willow has a pretty impressive memory then.
It does.
Oh.
Willow's T1 time is a whopping 100 microseconds, 5 times better than the previous generation of chips.
Wow.
It's a big leap forward in improving the fundamental building blocks of these quantum computers.
Okay, so we've covered Willow's accomplishments.
Yeah.
But now the big question is, what can it actually do that's useful in the real world?
Right.
So far, it seems like quantum computing has been about beating benchmarks or doing simulations that, while cool, could still be done by regular computers, just much slower.
That's true, but it's important to remember that we're still in the very early stages of quantum computing. It's like the early days of classical computers when people were just figuring out what these machines were capable of.
So we're in the punch card era of quantum computing.
Exactly. But the potential is immense.
Hmm.
And Google isn't just sitting around running benchmarks. They're actively working on developing quantum algorithms
Right.
that can tackle real-world problems that are simply impossible for classical computers to handle.
Okay, so all this talk about quantum computers and their potential has got me thinking,
Yeah.
why would the head of Google, Quantum AI, leave the booming field of AI to pursue this?
Right.
Because he believes that the two will become intertwined, right?
You're spot on. He sees quantum computing as a way to supercharge AI in some pretty amazing ways.
Okay, now I'm really intrigued. How would that even work?
Well, think about it. Quantum computers could be used to collect unimaginable amounts of training data for AI algorithms.
Wow.
Imagine having access to data sets that are exponentially larger than anything we can handle today.
Yeah.
That would be revolutionary for fields like machine learning.
So you're saying we could give an AI the ability to process information on a scale we can barely even comprehend.
Exactly. And that's just the tip of the iceberg. Quantum computers could also be used to design entirely new learning architectures for AI.
Okay.
Algorithms that operate on principles we haven't even imagined yet.
Wow.
We're talking about a fundamental shift in how AI learns and evolves.
Wow, that's pretty mind-blowing.
It is.
But let's bring it back down to earth for a second.
Okay.
What does all this mean for, the average person? What kind of concrete examples can we give them to show the potential of this quantum AI?
Well, let's start with something everyone cares about: healthcare. Imagine being able to design life-saving medicines with unprecedented speed and accuracy.
Right, I'm listening.
Quantum computers could analyze vast data sets of molecular interactions, identifying potential drug candidates that would take classical computers years, maybe even decades, to discover.
So instead of waiting years for new treatments, we could develop them in a fraction of the time.
That's the idea. And that's just one example. Think about designing super efficient batteries for electric cars that can store way more energy and charge way faster.
Yeah.
Or how about accelerating the development of fusion energy? Clean, virtually limitless power.
Wow.
These are the kinds of problems that quantum computers working with AI could potentially solve.
It's hard to even wrap my head around all the possibilities. It's like we're talking about magic.
It does feel like magic, but it's a magic rooted in physics and human ingenuity. We're on the edge of something truly extraordinary, and Willow is a giant leap forward in that journey.
This is where it gets really interesting.
Yeah.
What problems seem completely unsolvable today that quantum computers might crack wide open in the future?
That's a great question. Maybe we'll unravel the mysteries of dark matter and dark energy, or simulate the human brain with incredible accuracy. We might even be able to create entirely new forms of life. The possibilities are truly limitless.
It's almost too much to think about.
It is, isn't it? But that's the beauty of it. We're stepping into a whole new world of computation, and who knows what incredible discoveries await us.
It's mind-boggling to consider. We've covered a lot of ground here. Willow's achievements, the significance of error correction, the potential of quantum AI. It's mind-blowing stuff.
It really is, and we're just scratching the surface of what quantum computing might be capable of.
If you're as intrigued by all this as we are, we encourage you to check out Google's resources on quantum computing. They have open source software and even a Coursera course on quantum error correction.
It's a fantastic way to delve deeper into this field and maybe even contribute to its development.
Who knows? You might be the one to discover the next breakthrough in quantum computing.
Now that's an inspiring thought.
Definitely stay tuned because we'll be right back with more on this quantum leap.
You know, it's fascinating how we're discussing these incredible advancements,
Yep.
but most people probably don't even know what a quantum computer is.
You're right. Before we get too carried away with the possibilities, let's take a step back to the basics for a second. What exactly is a quantum computer?
Well, in the simplest terms, it's a completely different kind of computer that operates on the principles of quantum mechanics.
Okay.
Unlike our everyday computers that use bits,
Right.
either a 0 or a 1, quantum computers use qubits.
And qubits can be both 0 and 1 at the same time.
Exactly.
That's where it gets a little mind-bending, right?
The mind-bending concept is called superposition.
Okay.
And it's one of the key things that gives quantum computers their power. A qubit can exist in a combination of both states, opening up a whole new world of computational possibilities.
So it's like a coin that can be heads, tails, or both at the same time.
A perfect analogy.
Okay.
And this ability to be in multiple states at once allows quantum computers to perform calculations in parallel, exploring many different possibilities simultaneously. That's why they can tackle problems that would take classical computers billions of years to solve.
Okay, so superposition is one mind-bending concept. Yeah. But there's another one that's equally bizarre.
Yeah.
Entanglement.
Ah, yes, entanglement. The spooky action at a distance, as Einstein called it.
Okay, break that down for me. What is entanglement?
Imagine you have two coins that are linked,
Yeah.
so that if one lands on heads, the other one instantly lands on tails, no matter how far apart they are. That's entanglement.
Hold on.
Yeah.
You're telling me two qubits can be connected even if they're like on opposite sides of the planet?
Precisely. The state of one qubit instantly affects the state of the other, regardless of distance. It's like they have this invisible, instantaneous connection.
That sounds like something straight out of Star Trek.
It does, doesn't it? But
Yeah.
it's a real phenomenon that's been experimentally verified.
Wow.
And it's this entanglement that allows quantum computers to perform even more complex computations by exploiting the interconnectedness of these qubits.
Okay, so we've got superposition and entanglement, the
Mhm.
two superpowers of quantum computers.
Yeah.
But how do they actually use these superpowers to solve problems?
That's where quantum algorithms come in.
Okay.
These are specialized algorithms completely different from the ones used in classical computing.
Right.
They're designed to take advantage of these quantum phenomena, manipulating these entangled qubits and exploiting their superposition and interconnectedness to explore a vast space of possibilities and find solutions that would be impossible to reach with classical algorithms.
So it's like having a whole new set of tools and techniques for
Exactly.
solving problems.
Yeah.
But if I'm being honest, it still feels a bit abstract.
Okay.
Can you give me a real-world example?
Sure. Let's say you're a pharmaceutical company trying to develop a new drug.
Okay.
You need to analyze millions of molecular combinations to find the right one. A classical computer would have to go through each combination one by one, which could take years. But a quantum computer using a specialized algorithm could explore all these possibilities simultaneously, potentially finding the solution in a fraction of the time.
That's incredible. So we could be talking about significantly faster drug discovery, which could save countless lives.
Exactly. And that's just one example. The potential applications span across numerous fields, from materials science and finance to artificial intelligence and cryptography.
We've talked a lot about how quantum computers are different from classical computers,
Right.
but how do they actually compare in terms of performance? I mean, we heard about that supercomputer smackdown,
Yeah,
but are quantum computers always going to be faster?
that's a great question. Quantum computers aren't simply faster versions of classical computers. They're fundamentally different with strengths and weaknesses that make them suitable for different types of problems.
Okay.
For certain tasks, like those involving massive parallel computations or simulating quantum systems, they can be exponentially faster. But for other tasks like basic arithmetic or data processing, classical computers might still be more efficient.
So it's not a simple case of one being better than the other.
Right. It's more about finding the right tool for the job. And as the field progresses, we'll get a better understanding of which problems are best suited for quantum computers and which ones are better left to our trusty classical machines.
It's helpful to remember that classical computers have had decades to evolve and optimize.
Absolutely. They have a lot of catching up to do, but the progress they've made in just a few short years is remarkable. Imagine where they'll be in another decade or two.
Okay, so quantum computing is a game changer.
Yeah.
But what are some of the biggest challenges facing the field right now?
Well, as we discussed earlier, error correction is a major hurdle.
Right.
Qubits are incredibly sensitive to their environment, making errors more likely as you scale up the system. Willow's breakthrough in error correction is a huge step forward, but there's still a long way to go.
So it's a constant battle to keep these qubits stable and error-free.
It is.
What about building these quantum computers in the first place? It sounds like a pretty complex and expensive process.
You're not wrong. Building and maintaining quantum computers is a highly specialized and resource-intensive endeavor. They require extremely precise control over temperature, electromagnetic fields, and other environmental factors. It's not something you can just put together in your garage.
So we're not going to see quantum computers in our homes anytime soon.
Probably not, at least not in the near future. They're more likely to be accessed through cloud platforms where users can tap into their power remotely.
So kind of like how we access supercomputers today.
Exactly. And as the technology advances, we can expect to see more quantum computing services becoming available, making this incredible power accessible to a wider range of users.
That's exciting.
It is.
But with all this talk about the potential benefits, we also need to consider the potential risks.
Right.
What are some of the ethical considerations surrounding quantum computing?
That's an important point. Any technology this powerful comes with responsibilities. As quantum computers become more powerful and more widely accessible, we need to start thinking about the potential risks and how to mitigate them.
For example, what happens if quantum computers fall into the wrong hands? Could they be used for malicious purposes?
It's a valid concern. One of the biggest worries is the potential impact on cybersecurity. Quantum computers could be used to break the encryption that protects our online communications, financial transactions, and sensitive data. This could have serious consequences for national security, privacy, and the global economy.
So our current encryption methods might be useless against a powerful enough quantum computer.
That's the fear. We need to develop robust quantum-resistant encryption methods to safeguard against these threats. And it's not just about cybersecurity, we also need to consider the potential impact on jobs and the workforce. Could quantum computers lead to widespread automation and displacement?
It's a valid concern.
Yeah.
While quantum computers will likely create new jobs in areas like quantum engineering and software development,
Yeah.
they could also automate tasks currently performed by humans, potentially leading to job losses in certain sectors.
That's why it's crucial to have these conversations now before quantum computers become ubiquitous.
Right.
We need open and honest discussions about the potential benefits and risks, and to develop ethical guidelines and regulations to ensure responsible use.
I think it's also important to remember that technology is a tool, and like any tool, it can be used for good or for ill. It's up to us to shape the future of quantum computing and ensure it's used to benefit humanity. So much to consider. What's one key takeaway you want to leave our listeners with about the current state of quantum computing?
I'd say this. Quantum computers are not just faster versions of the computers we use today. They're fundamentally different, operating on the bizarre and counterintuitive laws of quantum mechanics. And because of this, they have the potential to revolutionize countless aspects of our lives, from healthcare and energy to materials, science, and artificial intelligence. We're on the verge of something truly extraordinary, and it's a journey worth following.
It's a whole new world of computation, and we're just starting to grasp its possibilities.
Exactly, and who knows what incredible discoveries await us.
Okay, that's a great place to end this part of our deep dive. We've explored the basics of quantum computers, the challenges they face, and the incredible potential they hold, including some of the ethical considerations that come with such a powerful technology.
But we're not done yet.
Right.
There's still so much more to discuss.
We'll be back soon with the third and final part of our deep dive into Google's quantum leap. So stick around, we've got more mind-blowing insights coming your way. Welcome back to our deep dive. I don't know about you, but I'm still kind of reeling from all the mind-blowing stuff we've talked about.
It's hard not to get excited about a technology with so much potential, wouldn't you say?
Absolutely. So far, we've been focusing on the technology itself.
Yeah.
But in this final part, I kind of want to shift gears and talk about the people behind it all.
Right.
We've talked a lot about Google,
Yeah.
but they're not the only ones racing towards this quantum future.
Right. It's a global effort. Researchers, companies, governments, everyone's pouring resources into quantum computing.
Yeah.
It's a truly collaborative endeavor, which I think is pretty cool.
Oh, it's not just about competition.
Yeah.
It's also about cooperation.
Exactly. There's a recognition that this technology could benefit all of humanity and that we can accomplish so much more by working together.
I love that. So who are some of the other major players in this quantum game? Who should we be keeping an eye on?
Well, besides Google, you've got IBM, Microsoft, Intel, and Amazon all making major moves. Each one is approaching quantum computing from a slightly different angle, exploring various technologies and architectures.
It's like a quantum race.
It is.
Everyone's vying to build the fastest, most powerful quantum computer.
Yeah.
But you said it's not just about competition.
Right.
So how does that work in practice?
Well, you see a lot of knowledge sharing in the quantum world. Researchers publish their findings, they collaborate to overcome these technical hurdles. There's a real sense of community, which is pretty unique in such a cutting-edge field.
It's amazing to think about the best minds in the world coming together to solve some of humanity's biggest challenges. But let's be real for a second. There are also potential downsides to this technology, right?
Yeah.
Some experts say that quantum computing could have major geopolitical implications, even shift the balance of power on a global scale.
That's definitely something to consider. We talked earlier about how quantum computers could break encryption.
Right.
That's a big deal for national security. If one nation gains a significant quantum computing advantage, they could potentially compromise the security of other nations' critical infrastructure and sensitive data.
So it's not just about technological advancement.
Right.
It's also about national security.
Exactly. Governments around the world are taking this very seriously, investing heavily in quantum computing research and development, not just for its economic potential, but also for its strategic implications.
It sounds like the space race of the 21st century.
It's a good analogy. And just like the space race, this quantum race is likely to drive innovation in related fields. Think advancements in materials, science engineering, even fundamental physics, all spurred on by pushing the boundaries of quantum computing.
Okay, so there's excitement, there's risk. It's all a bit overwhelming, to be honest. But I think it's important to remember that this technology isn't some futuristic fantasy. It's happening now,
It is.
and it's moving fast. What can our listeners do to stay informed about this rapidly evolving field?
Well, there are some great resources available online. Google's Quantum AI blog, for example, provides regular updates on their research and progress. You can follow experts on social media, read articles and books, or even take online courses.
And who knows, maybe some of our listeners will be inspired to pursue a career in this field.
Yeah,
The future of quantum computing needs bright minds from diverse backgrounds.
absolutely. Whether you're a student, a professional, or just curious, there's a place for you in this quantum revolution.
So as we wrap up this deep dive into Google's quantum leap, what's the one message you want to leave our listeners with?
I'd say this. Quantum computing isn't just a sci-fi dream. It's real, it's rapidly advancing, and it has the potential to reshape our world in profound ways. It's a journey full of challenges and opportunities, and we're all invited to participate. Stay curious, stay informed, and let's embrace this quantum future together.
Beautifully said. And on that note, we come to the end of our deep dive into Google's quantum leap. I don't know about you, but I feel like I just took a crash course in the future.
Me too.
Yeah.
It's incredible to think about where this technology could lead us.
Until next time, keep those minds curious and those imaginations firing. We'll be back soon with another deep dive exploring another fascinating topic. Who knows what we'll uncover next?